here's example 4 of finding the domain of the sum, difference, and product of functions. We are given two rational functions in this case, so the first thing I like to do is try to see if I can factor both these functions. I can definitely factor out the denominators because the denominator here in the f is the difference of the two squares. This is the same as saying x raised to the second power minus 3 raised to the second power. So the function f can be factored out to be 5x plus 1 over x minus 3 and then x plus 3. So keep the two term x times 3 and put the minus in one parenthesis and put the plus in the other. And do the same thing for this denominator as well, because this denominator is the difference of the squares of x raised to the second power and 5 raised to the second power, like that. So the function g with the numerator, it can be factored out to be 2 times x minus 2 over x minus 5 times x plus 5. Now with the factor rational functions, I can find the domain of the f functions right away by taking the denominator, x minus 3 times x plus 3, set it not equal to 0, and then set x minus 3 not equal to 0, and then x plus 3 not equal to 0. We know that x cannot be equal to positive 3 and x cannot be equal to negative 3. So the domain of the function f is all real number except x cannot be equal plus or minus 3. So on the number line, excluding negative 3, excluding 3. Going from left to right, we are going from negative infinity up to negative 3, but not including it. So it's an open interval. Union to go to the next part from negative 3 up to 3, but not including both of them. And then union going from 3, not including 3, all the way to positive infinity. All right, let's find the domain of the function g. Take the denominator, x minus 5, set it not equal to 0. Take x minus 5, set it not equal to 0, and then x plus 5 not equal to 0. So x cannot be equal to positive 5, and x cannot be equal to negative 5. So the domain of g is all real numbers, except, x cannot be equal to plus or minus 5. And of course, same thing for interval notation. Negative 5 here and 5 here. Going from negative infinity up to negative 5, but not including it, we got open interval from negative infinity, comma, negative 5. Going to the next part, put the union side, going from negative 5 up to 5, but not including both of them. So another open interval. And then union again, going from 5, not including it, all the way to infinity. And that is how we find the domain of f and g. Let's find the sum f plus g, which is 5x plus 1 over x minus 3 times x plus 3. And I'll leave some room in between here. And then plus, so you can see that. Let's see, well, we have the plus over here, so I'm not going to put this function inside the parentheses. 2 times x minus 2, my bad, and then over x minus 5 times x plus 5. Simplifying them a little more by finding the least common denominator, which is the product of all of these binomial factors in both of these denominators. So multiply this denominator by this product. And do the same thing on top. And of course, multiply this denominator by this one. And do the same thing on top. So that means the sum is going to be, let's see, we got 5x plus 1 times x minus 5. Oops, I'm not going to write that. Times x squared minus 25. All over x squared minus 9 times x squared minus 25. And then plus, let's see, 2x minus 4 times x squared minus 9. So I distributed 2 back in to get 2x minus 4. All divided by the product of x squared minus 9 and x squared minus 25. Same denominator, so keep it as 1. So we are going to have 5x plus 1 times x squared minus 25 plus 2x minus 4 times x squared minus 9 all over x squared minus 9 times x squared minus 25. And I'm not going to go ahead and simplify anything any further. I'm just going to go ahead and find the domain of the sum of the two functions here. And I can do that by taking the denominator, x squared minus 9 times x squared minus 25, and set it not equal to 0. So I'm going to have x squared minus 9 not equal to 0, comma, x squared minus 25 not equal to 0. So I got x squared not be equal to 9, x squared not be equal to 25. Taking the square root of both sides, I'm going to have x cannot be equal to plus or minus 3. And I get x cannot be equal to plus or minus 5. So the domain, oops, I already wrote it. The domain of f plus g is going to be all real numbers except, you can see that, x cannot be equals to plus or minus 3, comma, plus or minus 5. The reason why I just said the domain of f plus g is all real numbers except x cannot be equal to plus or minus 3 and plus or minus 5 is because besides the final step here, each of the previous steps have the same restrictions. This step has the identical denominators of x squared minus 9 times x squared minus 25. So the restrictions of this steps is still going to be x cannot be equal to plus or minus 3 and plus or minus 5. And the same thing can be said for this step as well. X cannot be equal to 3, x cannot be equal to negative 3, x cannot be equal to 5, and x cannot be equal to negative 5. So that's how I recognize it. Also, looking at the domain of the function f and g, the function f has the restrictions of x cannot be equal to 3 and x cannot be equal to negative 3. Function g has a restriction of x cannot be equal to 5 and x cannot be equal to negative 5. So taking into consideration of all of the restrictions of both f and g and the restrictions of every step of the simplification process of the sum of these two functions, I realized that all of the restrictions for the domain of the overall sum is plus or minus 3, plus or minus 5. So on a number line, in interval notation, I got negative 5 here, negative 3 here, maybe 3 right here, maybe 5 right here. I'm excluding all of them. So that means going from left to right, I'm going from negative infinity up to negative 5, not including it. So negative infinity, comma, negative 5. Jumping to the next part, put a union side, going from negative 5 up to negative 3, but not including both of them. Like that. Jump to the next part, put a union side, going from negative 3 up to 3. Put a union side again to go to this part, from 3 to 5, not including both of them, as another open interval. And then put a union side again to go to this part, from 5 up to positive infinity, but not including 5. So yeah, that's how we find the domain of the sum. Now what about the difference?